So I want to start by talking about the quick notes again. I know we did that like right at the end of class, but I'm going to set you guys loose on the check your understanding, which is using the 4 C's. And so I want to kind of talk through that process again. By the way, if you would like the 4C template to help you like we did with confidence intervals, I still have a bunch of those printed. You can find them in the back in the blue organizer. There is one of the pockets. It's 2 up from where the yellow pages are, or you could say 2 down from where the blue papers are. That's where you can get some more 4C templates if you would like to use that to help you on this homework. Because I know sometimes there's not a whole lot of room to write out all 4 C's in the space that it gives you on the homework, so the template might be helpful. I'll show you guys again at the end of class where that is in case you want to pick one of those up. So the 4C method for inference, there are a lot of things that we have to do in the choose. Just like with confidence intervals, we have to choose our procedure. Instead of a confidence level, we have an alpha. We still have to name our parameter, but now we also need the statistic and the hypotheses. So that's extra compared to the confidence intervals. So choose your procedure, set your level. In this case, it's alpha level instead of confidence level. Define your parameter, hypotheses, and statistic. Check stays exactly the same. There's nothing different about the check, except you're using P, not P hat. Remember, with confidence intervals, we had no idea what P was, but we had a P hat, so we had to use that. Here, we're saying we think we know what P is, and so we have to use P. You only use P hat when you don't know P. Calculate your general formula. Test statistic equals statistic minus parameter divided by standard deviation. And so for what we're doing here, then our specific formula would be Z equals P hat minus P over the square root of P times 1 minus P over N. Then you're going to plug in your numbers. Need to draw a picture. Remember, large counts, we're showing that this is approximately normally distributed, so you need to draw a picture of a normal distribution. Show your shading on there, just like we did back in chapter 7. Find your test statistic and your p-value. Remember, you use normal CDF to find your p-value. Then when you conclude, you have extra steps to do here versus the confidence interval. You have to interpret what that p-value means in context, and you have to make a decision and kind of wrap things up. So you either reject or fail to reject, and why. You do or do not have convincing evidence. All right. I'm going to give you guys... it's all 4 C's. It's the first time I'm asking you to do this on your own. Why don't we take 10 minutes for the check your understanding? If you would like to work with a partner or small group, I am perfectly okay with that. But we'll take 10 minutes to do that, and then we will go through the check your understanding. All right. I know you might not be all the way done with the conclusion, but I'm hoping that everybody has either finished or at least gotten to the calculate step so we can kind of see where we're at from here, and then we can do the conclusion together if you're not there yet. All right, so the setup to the problem. CNN once claimed that half of teenagers are addicted to their phones. A random sample of 180 teenagers was selected, and 72 reported that they were addicted to their phones. Is there convincing statistical evidence that the proportion of all teenagers who are addicted to their phones differs from 0.50? Use alpha equals 0.05. So here's what I had for my choose. This would be a 1 sample z-test for P. Do you have to write that down somewhere? Yes. 1 sample z-test for P should be somewhere in your choose step. They told us what to use as an alpha level. P hat, 72 over 180, my P hat is 0.40. You have to define P. If you did not define P, please add that to your page, because you can't talk down here about what P is or isn't if you've never told anybody what P means. P in this case would be the true proportion of all teenagers addicted to their phones. The ho is that it's equal to 0.50 because that was the CNN claim, was half of teenagers are addicted to their phones. The ha, it says differs from, and so we have a not equal to there. Anytime it says differs from, that would be a not equal to. This is a unique situation because we have not done a not equal to yet as a group together. And then you don't have to have this part, but I kind of stuck this in anyway. Our evidence for the ha would be, well, my p hat isn't the same as the claimed value for p. For the check step, random, we have a random sample of 180 teenagers. That's so we can generalize to our population. 10%, 180 is less than or equal to 0.10. If you write 10% with the percent sign here, that's perfectly fine. So 0.10 or 10% of all teenagers, so sampling without replacement is okay. And then large counts, n times p, and n times 1 minus p. We get 90 for each because p is 0.5. Please, please, please make sure you're using p and not p hat for your large counts. We do that so the sampling distribution of p hat is approximately normal. So far, so good? I'm not seeing anybody furiously writing, so I'm guessing that we feel reasonably confident, at least with our notes right now, for how to do these steps so far. Cool. Calculate. Sorry, my writing gets smaller as I move down the page because I started running out of room. So I'm going to walk you through this. This right here is what's on your formula sheet. If you look at that like golden formula sheet that you have that's the same that you'll get to use on the exam, it says standardized test statistic equals statistic minus parameter over, and then they say standard error, standard deviation, whatever. Z equals p hat minus p over square root of p times 1 minus p over n. So 0.40 minus 0.50 over the square root of 0.50 times 0.50 over 180. I always do my denominator first so that I can see what that is because I'm going to need my standard deviation over on my normal curve. And so I have negative 0.10 over 0.037, which gave me about a negative 0.268. What does that z-score tell us again? Before I even go look at the picture, what's the z-score telling us? How many standard deviations away you are from the mean. We are a little over 2.5 standard deviations away from the mean. Remember, at 2 standard deviations, that captures 95% in the middle. So the tails would each be 2.5% because the 2 tails together have to give you that other 5%. So I know this is going to be a very small probability because I am more than 2 standard deviations away from the mean. Then we do normal CDF, lower bound, upper bound, mean, standard deviation. We have to take this times 2 because this is a 2-tailed test. In picture form, this looks kind of like this. Here's my p hat, 0.40. The same distance away on the other side, since these are 0.1 apart, I would go 0.1 on the other side. You only have to do this when it's a not equal to, because it could be not equal to because it's too small, or not equal to because it's too big. So you go the same distance away from the mean on either side. When I did my normal CDF, I got 0.0034. I doubled that to get 0.0068. If you had something reasonably close to this, like anything reasonably close to 0.007, we're good. So if you had 0.0066, 0.0068, 0.007, somewhere in that general vicinity. Remember, if your numbers right here or your standard deviation is off a little bit from mine, that's okay. Statistics is much more interested in big picture than what was your third place out from the decimal and does it match mine. And then our conclusion, and I apologize, this is going to be written real small because again, I got to the bottom of the page and I started running out of room. First, we have to interpret the p-value. So interpreting my p-value, assuming the HO is true, p equals 0.5, there's a 0.0068 probability of getting a p hat of 0.4 or less, my shading. Hi. Yes. Mm-hmm. So 0.4 or less, or, because I had shading in another spot, 0.6 or more, purely by chance. No, I took it down there. I graded your test review. I graded the test review. That's okay. I have not graded the test.
Okay.
You're welcome. That's okay. Thank you for checking. Yes.
It's a two-tailed because it just says that it differs.
Mm-hmm. Yes, we want to know just is it different from, and so that makes it a two-tailed test, as opposed to is it greater than or is it less than. If it's a greater than or a less than, or they have language in the text that indicates that it's just a greater than or a less than, you're just doing a one-tailed test. But if we just want to know, is it this or could it be something else, then it's a two-tailed test. And again, with these two-tailed tests, when you go to draw the picture, when you interpret your p-value, look at your picture for how you have it shaded. So 0.4 was on this side of the mean, 0.4 or less, because we shaded to the left, or the same distance away on the other side of the mean would put us at 0.6, and then our shading goes to the right, so 0.6 or more. And then the end of my conclusion, should we reject or fail to reject? We should reject, because, yes, less than 5%. 0.0068 is less than 0.05. And so we're going to reject the null, we're going to reject the HO, because we do or do not have convincing evidence. We do. When you reject, you have convincing evidence. Because 0.0068 is less than 0.05, we reject the HO and have convincing evidence that the true proportion of all teenagers who are addicted to their phones is different from 0.5. Just looking at the conclusion, if you didn't know what p hat was here, just looking at the conclusion, would you be able to make an educated guess about whether it's less teenagers or more teenagers? If you just look at the conclusion. We're rejecting the idea that it's half. So could you say, based on the conclusion alone, that I think the proportion of teenagers is less than half, or I think the proportion of teenagers is actually more than half that are addicted to their phones? Could you make a decision just based on that conclusion? Not if you don't know p hat. If you didn't know p hat, just based on what's written in the conclusion there, I wouldn't be able to tell without knowing p hat. This is where a confidence interval can be more powerful than a significance test. A significance test is really good when I want to test a specific value. I want to test a claim that has been made, and I want to know whether that is likely to be the case or likely to not be the case. But on a two-tailed test like this, it doesn't really give me any indication of which way it goes or what the true value of p might be. I just know it's not 0.5. So this is where we get down into part B. And I know you probably didn't get down to part B yet, but I want to look at this together. We're not going to take the time to verify, but if you do a 95% confidence interval for this problem, instead of doing the 4 C's for a test, you do a 4 C's for an interval. The proportion of all teenagers who are addicted to their phones, the true proportion is in between 0.328 and 0.472. Now, do you have some kind of indication about whether it would be more than half or less than half? We also have a general idea of about where the true value of p would sit, right? So explain how the confidence interval is consistent with the significance test. What decision did we reach on the significance test? Reject. What are we rejecting? That it's half. The idea that the true proportion is half. Look at this confidence interval. Why does the confidence interval also support that same conclusion that it's not really half? What do you say? Both of the numbers are below 0.5. 0.5 is nowhere in this interval. The Ho value, 0.5, is not contained in the interval, so we would reject the Ho just like we did with the significance test. And if I were a researcher working with grant money to test out CNN's claim, and I went out and I conducted this study, I went to all the local high schools in Indianapolis and chose a random sample of students. We could do a significance test to see if it's really half. If I come up with it's probably not really half, then I would want to go on and do a confidence interval so that I have some idea of my next claim that I want to test. Some possible probable value for P. We're going to skip page 9. We got to make up some time somewhere. And the stuff on page 9, well, it's cool. It's not as beneficial as some of the other stuff that we need to talk about. So I want to go over to page 10, and we're going to look at the quick notes for what we were supposed to take away from page 9. And we're going to look at the check your understanding and walk through that together so that you guys at least have an introduction to this piece. And then Monday we'll do another problem with the 4 C's that's like page 10 stuff, right? All right, so on page 10, this is when we're dealing with a difference of proportions. Do you guys remember on the intervals when we had a P1 minus P2? One of the things I want to point out here, it's P1 minus P2, not P hat 1 minus P hat 2. P hat 1 minus P hat 2 is my statistic. I know this. I don't need a variable to represent something that is known. P1 minus P2 would be the true difference of proportions for whatever my context is here. The null is always the idea that P1 and P2 are the same. So their difference would be 0 if they come out to be the same. That will always be my null hypothesis on a difference of proportions test. And then the ha is either going to be less than, greater than, or not equal to, where not equal to would also make a two-tailed test. Interpreting our p-value and our conclusion, very similar to what we've done before, assuming the Ho is true, P1 minus P2 equals 0. There is a p-value probability of getting a p hat 1 minus p hat 2 of blank or more extreme, purely by chance. And then the conclusion, because the p-value is less than or greater than alpha, we either reject or fail to reject the Ho, and we either do or do not have convincing evidence for the ha. Remember, up here, when you are defining P1 and P2, and then down here at the end of your conclusion, because you're just using these letters, P1 minus P2, in all of your work, somewhere you have to tell people what P1 and P2 mean. So if you give the direction, you're saying this minus that, where it's not just P1 minus P2, it's context minus context. You're showing the direction. And so you want to have it in both of those spots. Let's go down and look at the check your understanding. This will go over kind of the big important highlights that we need when we're doing a difference of proportions test, and then Monday we'll actually run a difference of proportions test with the 4 C's. All right. So looking down at the check your understanding. According to a recent Gallup poll, people who are college graduates are more likely to report that they are satisfied with the way things are going with their personal life than people who are not college graduates. Of the 354 college graduates surveyed, 311 reported being satisfied with their personal lives. For the 384 people that were not college graduates that were surveyed, 301 reported being satisfied. Is there convincing statistical evidence for a difference in the proportion that are satisfied with their personal lives for all college graduates and all that are not college graduates? All right, let's talk about our hypotheses and defining that parameter of interest. I said a moment ago that the Ho, when we're looking at a difference, is always what? P1 minus P2 equals 0. When we're looking at a difference, it's always equal to 0 because that would mean there is no difference. So there's my hoe. What should the ha be? Is there convincing statistical evidence of a difference? If there's not a difference, then P1 minus P2 equals 0, right? If there is a difference, would P1 minus P2 equal 0? Could it be less? Could it be more? If it's less or more, it's different from 0. So my alternative hypothesis is that P1 minus P2 is not equal to 0. Do we have any evidence for ha here? What's P hat 1? How much? Sorry, I didn't hear. You don't know? That's fine. .878, so about .88. Yeah. P hat 1. This is for my college graduates. I highlighted this in blue up there. Of the 354 college graduates surveyed, 311 reported being satisfied with their personal lives. So 311 out of 354, which if I round it to 2 decimal places is just .88. What would P hat 2 be? About .78. So do we have evidence for a difference? Yeah, they're not the same. So I have some evidence. Is it enough to be convincing? Not yet. Not before I run a test, but I do have some evidence for this. All right, let's define our parameter. Since I have P1 minus P2 equals, P1 minus P2 does not equal, I need to define what P1 minus P2 means. When we talk about our parameter, I told you the other day there should be 3 words that pop right into your head. The true proportion, right? Only here we're subtracting. Give me a word that means subtraction. Difference. So this would be the true difference of proportions. For people that are satisfied with their personal lives, and we're going to do college grads minus not college grads. I have definitely had it happen before many, many times where students choose their P1 and P2 to be the exact opposite from mine, which is perfectly fine and does not affect your final answer in any way, shape, or form. It is okay to do that, but that's why it's so important to show me the direction, because if you're not getting what I got, I need to know why. We already answered number 2. Do the results provide some evidence for ha? Explain. Yep, because P hat 1 minus P hat 2 is 0.10, which is different from 0. On Monday, we'll do the calculate part. But for today, we're just going to jump right to somebody already calculated. And they calculated a p-value of 0.004. How would we interpret that? Assuming the hoe is true. What is the hoe? What's the hoe? P1 minus P2 equals 0. Assuming the hoe is true, P1 minus P2 equals 0. There is a 0.004 probability of what? Yep, of getting a p hat 1 minus p hat 2 of 0.10 or more, or going on the other side of my mean, going on the other side of 0, negative 0.10 or less, purely by chance. Why do I have to include that part in red? Because it's a not equal to. If it was a greater than or a less than, I wouldn't have to have that, but because it's a not equal to, I need to see both this, what you got from your p hat 1 minus p hat 2, and then I need to see the exact same distance away on the other side of 0. If we have a p-value, a probability value of 0.004, what do? Reject. Why? Because it's less than 0.05. So because 0.004 is less than 0.05, we reject the hoe. Because we are rejecting because we have evidence now. We have convincing evidence of a difference in the proportion that are satisfied with their personal lives. And notice again, I give my direction again one more time here. College grads minus not college grads. Your homework 9.2 that you picked up yesterday is due on Monday. You're going to practice doing the 4 C's, not for differences. We'll practice more differences on Monday. You'll see differences on the 3rd homework. Just practice it with P and P hat, just like we did on the Check Your Understanding today. Not this one, but the first one. So look back at page 8 to help you with the homework. If you want a template for the 4 C's, I moved the papers, sorry, but I made them easier to find. If you want a template for the 4 C's, it's the very bottom paper in that blue organizer. So you are welcome to grab a sheet if you want to do your 4 C's part of your homework on there instead of on the actual homework worksheet. That is perfectly fine. I think so, because I'm pretty sure it has it written on both sides, and I'm pretty sure that there's only 2 problems on there where it asks you to do the 4 C's.